Hello guys, come back with me Kevin Veranda. In this time I want to show you how to use software called SPSS for the data. This data. There are two variables. First is the dependent variable, and then we have independent variable. Okay. PRC is price of building, and then the SQF is the square feet. And then we have to prepare the blank document. What we're going to do in here is for the statistical data, classical assumption. The first we're going to do the classical assumption. There are divided into normality test, heteroscedasticity, multicollinearity, and autocorrelation. And then the second we're going to run the regression, and the last is the hypothesis. So let's do it. First, we go into the variable view. Click here. Okay. Type the name of the data, PRC, and the SQF. Okay, we type here PRC and the SQF. Okay. The decimal you guys can measure there if you want to the data, if you want to type the decimal or not. Okay. And then we're going to copy the data, paste it on the here. Okay. You can see this is decimal, yeah. If you don't want the decimal, you can make it 0, okay, like that. Okay. First we're going to do the classic assumption for the normality test. How to do it? First we're going to analyze, and then go into the regression, click linear. Okay. And then we're going to insert the data, insert PRC the dependent, and then SQF in independent. Okay. Sorry. Okay, do it like this, yeah. And then we're going to the save. We check here, yeah. Don't forget to click here. Okay. And then we continue, and then we click OK. Now it will show you the output of the data, yeah. We doesn't need this yet. We're going to find the normality using the method Kolmogorov-Smirnov. Okay. So if we're going to do the method Kolmogorov-Smirnov, we have to go to the analyze, and then we click to the non-parametric task, and then click legacy dialogues, and then we're going to one sample KS. Okay. Click here, and then we insert the unstandardized residual one, yeah. Okay, here, and then the task distribution is normal, yeah. Okay, and then we click OK. Now we can see the data, yeah. We're going to copy it to the cost support. Okay. Okay. For the normality test, the condition is if a sim sig tail is bigger than 0.05, then the residual is distributed normally. Okay, we can see, yeah guys, yeah, in here. Okay, a sim here is 0.200. This is bigger than 0.05. So the residual is distributed normally. Okay guys. Okay, and then we go into the second is the heteroscedasticity using the method Gladster. Okay, we come back to this data. Okay, heteroscedasticity is the cross section data, guys, yeah. So please if you guys don't know the cross-section data, you guys need to just search in the Google, in the browser, on anywhere, guys. Okay, first we go to transform, and then we click compute variable, yeah, compute here, and then the target is we type in res_2. Okay, and then we go to the function group, click arithmetic, and then we click EBS, click 2 times. Okay, it's going to show up here, and then we type res_1. Okay, and then we click OK. Okay, it's going to show up here, and then we click analyze regression, and then we're going to the linear. We insert the dependent variable, we switch into the res2. Okay, guys, and then we go to the save, we unchecklist the understand set in the residual. Okay, we unchecklist, and then we click continue, and then we click OK. Okay, the output that we need for the heteroscedasticity is the coefficient, yeah. Okay, we click here, we copy, and then we put it here, and then the condition is if a sim sig value is bigger than 0.05, then the variance are constant. Okay, so there is no problem with the heteroscedasticity. Okay, we need the asim value over here, guys, the data. Okay, we can see the asim sig value is 0.50 like that. Okay, this is bigger than 0.05. Okay, so there is no problem with the heteroscedasticity. Okay, guys. Okay, and the third, we're going to the multicollinearity using the method VIF and tolerance factor. Okay, guys, how to do it? We come back to the file. We go to the analyze, and then do the regression. The regression linear. We click linear here, and then we're going to the change the rest to the dependent variable price. Yeah, click here, and then after that, we're going to the statistic over here. We check with the collinearity. Okay, collinearity diagnostic, and then estimate, and also model fits. Okay, guys, and then continue. We go to the save, we unchecklist. Yeah, this is also already unchecklist, and then we continue. We click OK. So the output for multicollinearity is collinearity diagnostic. No, coefficient A. Yeah, the output is coefficient A. Okay, so we're going to copy, go to the document, and then we're going to insert here. Okay, Okay, so what is the condition? The condition is if tolerance factor is bigger than 0.1, okay, then independent variable are independent with no high correlation. Okay, so there is no problem with multicollinearity. Okay guys. Okay, the second condition is if VIF is smaller than 10, then independent are independent with no high correlation. So there is no problem with multicollinearity. Collinear. Okay guys. Okay, so we're going to prove it. Okay, tolerance with toler and then with VIF, yeah. We're going to use this data. Okay, the tol is 0.1, the VIF also 1. Okay, if this data is bigger than 0.1, so there is no problem with multicollinearity. Okay, if this smaller than 10, so there is no problem with multicollinearity. Okay, so that means this data is correct. Okay guys, the data that we use is balanced, so we doesn't need to use this data. Okay guys. Okay, for the fourth we going to use the last, yeah, autocorrelation using the method run test and Darwin-Watson. Okay, we come back to this. Okay, we click analyze and then non-parametric test, legacy dialogues, and then we click runs. Okay, after that we're going to insert unsynthesized residual 1. Okay, and then click OK. So the output will be the run test. Okay guys, copy it and paste it here. Okay, after we copy and paste it here, we're going to see the condition. Condition: if a sim seek to tail is bigger than 0.05, then the residual are independent throughout the period. Okay, then there is no problem with auto correlation. Okay, we're going to prove. Okay, assume to tell ya. Okay, assume. Okay, it's 0.737. Okay, this is bigger than 0.05. Okay, so there is no problem with the auto correlation. Okay, the last is we're going to do the second part is the regression. For the run regression, we're going to back here, we click analyze, and then we click regression, and then we click linear. Okay, click linear. We this is already correct, dependent and independent variable, and then we go to the save, and then we checklist the adjusted we click here, okay, and then continue. We're going to the statistics, and then we click descriptive statistic, and also we click Darwin-Watson. This is not mandatory, you guys can choose what you guys want to use, and then continue, click plots, and then we click checklist the histogram, and then the normal probability plot, and then continue. After that, okay, the data that we're going to use is the coefficient. Okay, you guys can see this data is not mandatory. If you guys need the histogram, you guys can use one of my I can show you guys like that idea, like that. Don't forget to checklist the histogram. Okay, the data that we need to use is the coefficient A. This is data, okay, this data coefficient A, we copy it, and then we pass here. Okay, after we pass here, the condition significant if sig p value is smaller than 0.05. okay, then the independent variable is significant. Okay, so we're going to prove it. We're going to find the sig value here, okay. The data is 0.010. okay, so this is smaller than 0.05. so the independent variable is significant. Okay, how about the hypothesis? So the hypothesis is, we can see if the data significant, this is have a positive impact, okay. So the hypothesis will be the SQF square feet has positive impact on house price. Supported, meaning that the surface the square feet, square feet large is large or bigger, is more expensive, is making more expensive the house price. Okay, so that's all guys. This is the data for the software SPSS. For the link for download this application, I will put it down on the YouTube in the subscription, so you guys can see it there. That's all guys. If you guys have any question regarding this, I will show you guys, and that's all. Maybe if you guys have any inquiries, you guys can talk with me. That's all. Thank you. See you in the next video.